All right, kiddos. Hello. Snow day 2. Hopefully everyone's doing all right, safe, and more. Um, so I'd like to follow up on the second video and go over the solutions for the two problems I asked you to do on your own. And then at the end of this, I will post on Canvas 4 or 5 problems I want you to try on your own for tomorrow. So here we go. One of the equations, trigonometric equations that I did not work through yesterday on the video was this tangent of x equals 1. And the reason I chose to decline that for now is simply because I think it's just one where we can think through. Right? So I presented to you some algebraic problems yesterday. We factor some of them, or we solve directly. 4 and 5 we factor, set each factor equal to 0 and solve. Where 1 and 2 we just solve directly, either using our knowledge ultimately of the unit circle or using the inverse sines, cosines, etc. in our calculator. Okay, so I would like to go over those two that I asked you to do, and this tangent of x equals 1. So for tangent of x equals 1, I think it's easiest if we just think of that as sine x over cosine x equals 1, right? So I'm going to replace with that with the definition of tangent. And now I'm going to multiply both sides by cosine x, right? So basically here's where I am, right? If tangent of x equals 1, that happens whenever sine of x is equal to cosine x, right? And so in order to think this through, we have to think about, well, what's the sine, what's the cosine, etc., etc., and for what angles x, and let's assume we're still solving between 0 and 2 pi on that interval. For what values of x does that happen? Sine of x equals cosine of x. Well, many of you are probably thinking, okay, we have a 45, 45, 90 reference triangle, right? And it has to be in either quadrant 1, where both the sine and cosine are positive, or quadrant 3, where both the sine and cosine are negative, right? So therefore, of course, most of us, I think, can come up with a principal solution, that being pi over 4, right? Where the sine of x here is pi over 4, right here, right? Where the sine of x is root 2 over 2, and the cosine of x is also root 2 over 2, right? So one solution is certainly pi over 4, right? But that same triangle, that same reference angle will occur also in the third quadrant, where both the sine and cosine are negative. So here's my 5 pi over 4. Right here, cosine of x negative root 2 over 2, and the sine of that x is negative root 2 over 2 as well. Cosine of x equals sine of x, when x equals 5 pi over 4. Right? So that's a particular problem for which you can just reason through, I think. There are other ways to do it, but I think that's the easiest. Okay, let's talk about the two I asked you to complete for at the end of the video. And I'm looking at this particular problem, and what I suggested that you do is get rid of that sine squared, right? The reason it being is that we have cosine squared and a cosine, and well, we need apples and apples. Right now we have apples and an orange, right? So I want all the variable to be like terms, and unfortunately cosine of x could be my variable here, cosine of x, but then I have a sine of x, I have a non-like term, right? So I'm going to, by the Pythagorean identity, just replace sine squared with 1 minus cosine squared, right? So that's easy enough. So that becomes 1 minus cosine squared of x. And let me see if I can do a better job with this today. Format. Nope, sorry. So that wants to be cosine squared of x. Daggone Google Docs. Okay, that's cosine squared of x. And if this were a helpful program for math, it would be very easy to do, but it's just, oh, there we go. Okay, and now I have cosine squared of x, cosine of x, and another cosine squared of x. So this is actually much easier because now I have just cosines, right? I've eliminated the non-like sine squared x term. Right, so now I'm going to set it all equal to 0 and hope it factors, right? So in order to do so, I'm going to add cosine squared to both sides. Right, so that ends up giving me 2 cosine squared x on the right. Nope. Oh, 2 cosine squared of x on the right. Right, and then plus cosine of x. And then I'm going to subtract that 1 and set it equal to 0. Right? And now I'm in factor mode, right? I'm going to try to factor. It's just like, so it's kind of like 2x squared. Oh, plus x minus 1 equals 0, right? But it's in terms of not x but in cosine. 2 cosine squared x plus x minus 1 equals 0. So we would kind of treat the variable here as if it were cosine of x instead of an x, right? But this is quadratic in terms of cosine of x, whereas this is quadratic in terms of x, right? So my approach is still the same. So I'm going to factor, right? Or I'm going to see if it factors. So 2 cosine x, I'll leave a little space, and then cosine x. Of course, first times first needs to be 2 cosine squared. Right, and then what I put here and here has to multiply to be -1, and then the outers and inners have to add to be cosine of x. So I'm going to put the plus 1 here, and I'm going to put the minus 1 over here, and that is the way in which this quadratic in terms of cosine factors, right? First times first gives me 2 cosine squared, outer times outer gives me plus 2 cosine of x, minus 1 cosine x, that gives me with plus, leaves me with 1 cosine x, and of course last times last is -1. Okay, so I factored just as I would this particular quadratic in terms of x, and now I set each factor equal to 0, right, and solve. So now I have 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0, right, and I want to solve each one individually. Alright, so I'll start with the one on the left, the first factor. I'm going to add 1 and divide by 2. So ultimately I end up with cosine x equals 1/2. Okay, and that 1/2 is a nice number. I know what angles x have cosine values of 1/2. Okay, I'll bump over to the other one. Cosine of x equals -1. And again, that -1 is a nice number. I know those angles x for which the cosine of x is equal to -1. Right? If we don't remember, we can always certainly work back to, the unit circle. So let's do that. So here's the unit circle. I want the cosine of x, let's solve the first for x. I want the cosine of x to be equal to 1/2. So, let's consider the angles or the quadrants first in which that happens. Cosine's the x value, so I either want to end up in the first or fourth quadrant, and I need an x value of 1/2. So here I am right here, up at 60 degrees, or pi over 3. So pi over 3 is what's called my principal solution, pi over 3. And then that same reference triangle, reference angle, all the way over here at 5 pi over 3 also has a cosine of 1/2. Okay, so the two solutions between 0 and 2 pi are pi over 3, and then the same reference angle, reference triangle in the fourth quadrant, 5 pi over 3. Okay, so this particular factor, x is pi over 3 and 5 pi over 3. Okay, let's think about where the cosine of x is equal to -1. Let's beckon back to the unit circle if you don't remember. Remember, cosine is the x value. -1 right here is one of my quadrantal angles, my terminal points. -1, 0, so I want to end up at this point. And so, therefore, the only solution on 0 to 2 pi is pi radians, or 180 degrees. Okay, well, x equals pi. Okay, so this particular original quadratic has 3 solutions on 0 to 2 pi. Pi over 3, 5 pi over 3, that makes the first factor equal to 0, or pi, which makes the second factor equal to 0. Okay, let's work on to the next problem, right? And for this one, it's very similar in that I have cosine and a sine, and I want apples and apples, right? So far I have cosine of x and sine, that's apples and oranges. So it's always helpful to try, if we can, to begin by inserting an identity. So sine of 2x by identity is 2 sine x cosine x, excuse me. And now I think many of you will say, well, now I can get my algebra on and factor out not an x but a cosine of x, because both pieces contain a cosine x. So I'll do that now and factor out a cosine x, and what I'm left with is a 1 plus 2 sine x equals 0. So again, resorting back to begin by inserting the sign of a double angle identity. That's helpful because now I can factor out a cosine of x from both the first term and the second term. And now that's even more helpful because when I set each equal to 0, as I would, I can solve both pretty readily. Right? Cosine x equals 0, remember that? Pi over 2, 3 pi over 2, at least on the interval 0 to 2 pi. If you don't remember it, it's cool. get to remember it so you can live a happy, healthy life. But if we don't remember it, we can certainly look over the unit circle, right? Cosine is 0 here, pi over 2, and then here again at 3 pi over 2. Okay, so the first solution is pi over 2, and then all the way 3 pi over 2. And then the second factor, well, let's think about that. I'm going to subtract 1, divide by 2, so this is what I end up with. Right? And again, if we don't remember where the sine of x equals negative 1/2, let's think about the unit circle. Sine is the y value. It's negative in the third and fourth quadrants. So I want this point right here. Oh, wrong. This point right here, the y value. And I want this point right here, the y value. Right? So I get 7 pi over 6, again with a pi over 6 reference angle in here, which is 30 degrees. Opposite side, therefore, would be 1/2 because it's in the third quadrant, negative 1/2. So 7 pi over 6, one such solution. And then another solution is 11 pi over 6. Again, with that same pi over 6 reference angle, when you create that reference triangle, opposite side 1/2, fourth quadrant, therefore negative 1/2. Right? So 7 pi over 6, one solution, and 11 pi over 6, the second solution. 7 pi over 6 and 11 pi over 6. Okay? So there you have it. Right? Again, we're solving trig equations, we're using factoring, and then we're setting each factor equal to 0 ultimately. And then for these two problems, using the unit circle to work through those solutions if we don't remember them already. Okay? I'm going to put a couple problems in Canvas for you to complete. I'll see you tomorrow, hopefully. Bye-bye.